Hey guys, Mrs. Dominiak, and we are going to go over some benchmark stuff from Unit 1. So this is part 4 video. So we're going over scientific notation and significant figures. Mostly scientific notation. We're going to have a little bit of sig figs, and we're going to talk about why things are only significant that are significant. So we had some weird rules about zeros that you keep and don't keep. This will explain why. So first, scientific notation, it's important to know the correct format. So you have some number times 10 to some power. So this is called your coefficient, that front number. It has to be 1 is the smallest number it can be. It can be 1, but it cannot be any smaller than that. And then it has to be less than 10. So like 9.99999 is fine. Basically, any number that's a digit, a decimal, and then some other stuff. So if you look at where your decimal is, you can't have anything more than one digit to the left of that decimal in the coefficient. You have a base 10, and then you raise that base to some power. So whether that's a positive or negative, doesn't matter, but it has to be an integer, meaning a counting number. So this could be 10 to the first, 10 to the second, 10 to the 402, 10 to the negative 23, 10 to the negative 50. Things it cannot be is like 10 to the 1.2 power. You can't have that. You can have 10 to the first, you can have 10 to the second, but you can't have any decimals here. Why is this important? Why do we do it this way? Well, 6.2 times 10 is 62. What did we do there? We took the decimal and we just moved it once to the right. Whenever you multiply by 10, you move the decimal one spot to the right. So 6.2 times 10 times 10, you move the decimal 2 spots, because see how your decimal would actually be right here. 3 tens, so 1, 2, 3. Notice the decimal was between the 6 and the 2, and now the decimal is 3 spots to the right. The decimal was between the 6 and the 2. Now you can't see it, but it's right here. And so on. So what's 6.2 times 10 to the 6th? Well, what we would do, since we have a positive exponent, you move the decimal to the right, because that means you are multiplying by 10 6 times. So 6,200,000. What's 6 divided by 10? Well, when you multiply by 10, you move the decimal to the right. When you divide by 10, it's the opposite. You move it one spot to the left. So that's not right at all. Should be this. There we go. 0.62. Divide by 10 and divide by 10 again. Move the decimal 2 spots to the right. So see how to the left. How the decimal was 6.2. It's now 2 spots to the left. Here we go. Divide by 10 3 times, 3 spots to the left. Divide by 10 4 times, 4 spots to the left. Here we go. So what's 6.2 times 10 to the negative 6th? Well, you would take this decimal and move it 1, 2, 3, 4, 5, 6 spots. So it was here 1, 2, 3, 4, 5, 6 spots. Okay, standard to scientific notation. Here are the steps to follow. And in your worksheet, at the end, you've got something to solve. So I'm going to go through the steps, and as I go through it, you're going to fill out stuff on the bottom. So first, you're going to identify all the significant figures, or sig figs. In this number, remember your first non-zero, so that would be the 8, and then your last non-zero. That's the 2. Is there a decimal at the end? No decimal, meaning these zeros are just placeholders. They're not part of the actual measurement. We'll explain that again later in the video, but here you go. So these are your only sig figs, 8, 0, 2. The rest is just telling you how big the measurement is, not any quantity about the measurement. So now you're going to rewrite so you just keep those sig figs. So everything we just boxed in as significant, you're just going to rewrite. So 8, 0, 2. That's the first or the second step in the method. 3, you're going to put your decimal after the first digit. So this is 8 is my first digit, so I'm going to put a decimal right here in between them. So it's not 802, it's 8.02. Now if you notice 8.02 is certainly not the same thing as this 8 giant number. Big number. Then you're going to count how many spaces are between the new decimal position and the old or the original decimal position. So in this number, my decimal's here. In this number, in the bottom, my decimals between the 8 and the 0. So how many spots did we move? 3, 6, 9, 12, 15. There are 15 spots here. So you're going to use that number as your exponent. So I got 15 spots, so it's times 10 to the 15th. Last thing is determine if your coefficient or your exponent, if your coefficient needs to get bigger than your original number, or does it need to get smaller? So 8.2, does that need to grow to get to your original number, or does that need to get smaller? Well, this original number, 8 bazillion, I don't know what that is, someone look it up and let me know. That's a lot bigger than 8.2. So since it's bigger, I need to keep this positive because I need to multiply by 10 a bunch of times to make it bigger. So here's an example. Here are my sig figs, 703. I write those. I'm going to put the decimal after the 7, and I moved it 1, 2, 3, 4, 5, 6 spots. 7.03 times 10 to the negative 6. It's going to be negative because 7.3 needs to get smaller to be 0.000703. This one, my sig figs are 503. That's what I keep. The decimal goes after my first non-zero, so it's going to go after the 5. Between here, my new decimal position, and here, my old decimal position, this has 3 spots. Notice it goes 1, 2, 3. It's positive because 5.03 needs to get bigger to be 5,030. All right, this guy, not significant, not significant, not significant. Here's my sig figs, 53882. I put my decimal after my first sig fig, so 5.3882, and then I count my positions from here, my old decimal, to here, my new decimal, which is 12 spots. I'm going to make it negative because 5.3882 would need to be divided by 10 12 times to make it smaller. Each time would make it smaller. So if I divide by 10, here's my once, 2, 3, 4, I'm moving my decimal, and I would move it 12 times to be way over here, and this would all fill with zeros to make my original number. 2,030 moles, another mistake. 2.03 times 10 to the 6th moles. All right, so I told you earlier sig figs. Well, remember that over here, these zeros aren't significant. Why? Well, look, they go away as soon as you go in scientific notation. This doesn't actually tell you anything about your measurement. These digits tell you what was measured. These are just placeholders to say how small your measurement is. Also, 10 to the negative 6th is the same thing as micro. The prefix 10 to the negative 6th is micro. So I could say instead of 10 to the negative 6th, replace that with this micro. So 7.03, cross that off, micrometers. 7.03 micrometers. And notice those zeros don't exist in this. They just have to do with what unit it is and not the actual measurement. Or like this down here, the zeros after the 3 are just telling you how big that measurement is. 10 to the 6th is the same thing as mega. So I could say 2.03 times 10 to the 6th moles, or I did it again, forgot to correct it there too, 2.03 megamoles, like this. So scientific notation to standard form. So 4.02 times 10 to the negative 8, that negative 8 means you're dividing by 10 8 times. So every time you divide by 10, you move your decimal to the left. So if the decimal is positive, move it to the right, but it's not. If the decimal is negative, like our example, you're going to move it to the left. Fill in any spots with zeros. So here's my coefficient. Times 10 to the negative 8th. Instead of writing times 10 to the negative 8th, I'm going to move my decimal. So here's the decimal. 1, 2, 3, 4, 5, 6, 7, 8. Here's the new number with the moved decimal. So it's no longer here. And I suggest as soon as you figure out where the decimal goes, put an X through here so you know not to include it in your measurement. This little hump is filled with the 4, but the rest don't have anything, so you have to fill them with zeros. So here's your final measurement. Ta-da! All right, so how do we do this one? Well, you're going to move your decimals. So I've got 4.032 times 10 to the 8th. This is a positive 8, so I'm going to move my decimal to the right. Here it is. 8.33 times 10 to the negative 10th. Why don't you give it a try first? So pause your video and see if you get what I get. Did you get this? Good. If not, remember you have to ask the teacher, so there should be someone walking around or at the computer that can answer your question if you didn't get it right. All right, this one, 3.7 times 10 to the negative 3 liters. Why don't you freeze your computer, write what you think the answer is, and then come back. Did you get this? If you didn't, go out, talk to the teacher. All right, so now it's your turn completely to answer these questions. You're either putting it in scientific notation or you're taking it out and putting it into standard form. So freeze your video, answer all of these questions, and we'll be back in a second. Here we go. Okay, 6.03 times 10 to the 9th is here. Remember, you can count easily with thirds. 3, 6, 9. Here we go. 4.2 times 10 to the negative 3. This, you have to move it 4 times. 1, 2, 3, 4. Fill in that spot with a 0. 18,010. This, you moved it twice. 1, 2, 390. This, you're going to move it 8 times, but to the left. 1, 2, 3, 4, 5, 6, 7, 8. So we moved it from here. 1, 2, 3, 4, 5, 6, 7. Uh-oh. 8. And our last one. So this would be, we would have to move it 1, 2, 3 to have one digit to the left of the decimal. So this would be 2 times 10 to the negative 3. There you go. All right. Also, some things might not be in proper scientific notation when you get a measurement. Remember, your coefficient has to be more than 1 or 1 and less than 10. So you can only have one non-zero to the left of the decimal. So if you get a decimal that's not in proper form, you first just fix the coefficient, then multiply by the base 10 you saw. For example, if we have 45.02 times 10 to the 8th, how do we make that in proper scientific notation? Notice 45.02 is greater than 10, so that won't work. So you have to put it in proper form. 45.02 is the same as 4.502 times 10 to the 1st. So plug this in instead of 45.02. So 45.02 times 10 to the 8th is the same thing as 4.502 times 10 to the 1st. That's your original coefficient. And then you still have the times 10 to the 8th from here. 10 to the 1st, 10 to the 8th, you have 2 10s raised to powers being multiplied. When you multiply, you add up high. So you have to add up these coefficients. So 4.502 times 10 to the 9th, because 1 plus 8 gives you 9. How about this one? So this number, 0.0004407, that's a lot less than 1. So first fix this. This would be 4.407 times 10 to the negative 4th, because I would have to move in a decimal 1, 2, 3, 4 spots. 4.407. This number needs to get smaller to be my original number, so that's why it's a negative 4 exponent. So now plug all this stuff in for your original coefficient. Here we go. Multiply, you add up high. So you've got negative 4 as an exponent and 13. Well, what's negative 4 plus 13? Sometimes it's nice to think of it like this so you don't forget to put that negative sign. That's going to be 4.407 times 10 to the 9th. All right, it's your turn, so you know what that means. Freeze the video, answer these 3 questions. Determine if it's in proper scientific notation or not. If it is, just label it as proper. If it is not, then fix it. Okay, see you in a second. All right, so you've answered your 3 questions now. The first one, 8.000004 times 10 to the negative 19th, that is in proper scientific notation. 8.000004 is between 1 and 10, so that's good. Your next one, 0.404 times 10 to the negative 13th, is not improper scientific notation. Do you know why? This coefficient is less than 1. If it's less than 1, that's no good. So you have to fix this first. So if I want to fix that first, I would make it 4.04 times 10 to the negative 1. If I took 4.04 and I divided it by 10 once, it would give me 0.404. When you multiply, you add up high. So your exponents get added together. Negative 3 plus 13. So 4.04 times 10 to the 12th. Notice that your numbers, your sig figs, don't ever change. So this 404, that's still there, 404. 53 times 10 to the 15th. Do you think that that's proper? No. Why not? Well, because it's greater than 10. So fix that first. 5.3 times 10 to the first, because that would give you 53. Now, don't forget about your 10 to the 15th. So we multiply, you add up high. We've got our exponents as 1 and 15 we're adding together, so it's 5.3 times 10 to the 16th. All right, if you had any questions on this video, make sure you ask the teacher before moving along, and then I'll see you on the next one. Bye!